Welcome back to today's video. In today's video, we're going to focus on data cleaning, in particular, preparing our data for our machine learning algorithms. In particular, we're going to focus on separating the predictors from the labels, as well as replacing missing data fields or missing data values from our housing data frame object. Before we get today's video, make sure you hit the subscribe button down below and like the video for more content just like this. Let's get right into it. All right, let's take a look here at our first section here. We first want to separate our predictors from our labels. Remember, going back to our CSV file, you see that we have several predictors here: the housing median age, households median income, as well as ocean proximity, and several other predictors that we use in order to calculate the median house value. Remember, the median house value is the goal that our machine learning model is going to predict. That's our goal of what we want it to predict. And so what we're going to do first of all is we're going to separate the predictors in this case from the actual labels, what we want the machine learning model to output. And so in order to do that, we're going to take our stratified training set, which we generated several tutorials ago, and we're going to remove, or we're going to drop, the housing median value. So we're going to remove that particular column as well as all its data values from the stratified training set, and we're going to set it equal to the housing data frame there. So let's go ahead and print that out, and let's go ahead and view this data frame here. So when we print it out, you can see here that we have longitude, latitude, housing median age, all the other attributes that we have, but we have excluded the median house value because that's what we want our model to output. All right. And then we're going to just take the housing labels. So the housing labels basically is the median house value. So we're just going to copy the median house value. Let's go ahead and print out that. So we're going to say housing labels. Again, remember, the label is what we want our model to output. Let's go ahead and print that out. And you see here that we have all of our labels right over here in terms of what we want our model to output. Now, remember, this is a stratified training set. So you see here that each of the column or the row indices is not written in order because of the fact that we had to separate them based on characteristics that were similar. Okay, so both based on separate strata, essentially, right? But you are noticing, obviously, that the rows do correspond to each other. So you're seeing here row 12,655 corresponds to the first row 12,655, and so on and so forth. So the rows obviously do correspond to one another, and that is very important. All right, so we separated our labels from our housing object. And the reason why we were able to extract the median house value after dropping it is because, remember, we dropped it from the housing data frame object. We didn't drop it from the stratified training set. So that's how we were able to access it again by using the stratified training set instead of using housing. If we tried to say housing median house values, it would cause an error. So you see here, it's taking some time. Yeah, it caused an error here. It's saying here that if you go to the very bottom, it says here median house value. It can't find that key in the housing data frame. And so you're going to have to use the stratified training set because we didn't actually assign it in any particular way. All right, so you're seeing there how we separated the labels from the predictors. All right, that's what we were able to do there. Now, what we want to also do, we want to fill in any missing values. So if there are any missing values in any of the data fields, when I say data field, I'm just referring to a column in the data frame entire object. But if there's any missing values in any of those fields, we want to obviously fill them in because we don't obviously want to send in data that has unfilled values. And so because of that, there's basically three things that we can do in this particular perspective. If we notice that there's a particular value that is not filled, we can do one of three things. The first thing is we can remove that entire column from our training data, right? So remove the entire column from the training data. That's obviously not very much of a good idea. If you just have one row out of, let's say, 15,000 rows that isn't filled, getting rid of the entire column doesn't make sense, right? If you just have one value, not row, one value. So that wouldn't make sense. Another thing you can do is you can get rid of that entire row or that entire district. So let's say, for instance, that this row 8 over here, let's say this value were not to be filled, let's get rid of the entire row, right? You could do that, but obviously that wouldn't be very useful because if just one value is not filled, then why would we get rid of the entire row? It would make more sense to just maybe delete that one thing or replace it, right? So the last method is the best method, and that's to set that value, that empty value, equal to some value. You can set it equal to 0. Some people do. Some people set it to equal to the mean of that entire column. Other people set it to the median. The best way to do that is by the median, because remember, if you're able to get the median, remember the median means that 50% of the values are below that value and 50% of the values are above that value. The mean might be also an alternate option. Although that being said, if you were to select the mean can be very much affected by outliers, if you remember, whereas the median is less likely to be affected by outliers. And so that's very important. So the median, the reason why the median is not is because the median actually, regardless if a value is very far above the general range of all the values, it will be not very much affected, whereas the mean will very much be affected by those outliers. Setting it equal to 0 doesn't really provide us with any data and might just throw the model off, so that doesn't make much sense either. So the median makes most sense because we know that 50% of the values in that particular column will be below that value and 50% will be above, right? So the median makes the most sense from that perspective. All right, let's take a look at this here. So option 1 is again to remove that entire column from the housing data frame object. So we can call the drop NA. Basically, that function will just drop that entire, it won't drop the entire column. Sorry, let me rephrase that. Sorry. It'll drop that row, right? That particular row when it finds that there's a not filled field. So if there's a particular district that has unfilled data, now in particular, this one's going to be using the total bedrooms. So it's going to be looking at a particular attribute, in particular, the total bedrooms. So this is just looking at the total bedrooms, by the way. It isn't looking at everything. So just looking at the total bedrooms, if it finds that one of the rows is unfilled, it's going to delete that entire row. And so you're seeing here that it calls the drop NA function. NA just means not applicable, or in this case, it means not filled. So NA, in that case, it's going to remove that entire row. So it finds this row is unfilled, it'll remove that entire row or that entire district, right? Remember, each row represents a district. The other one here, option 2, is to get rid of the entire column. So it's going to drop the entire column, just the entire column outright. It's just going to drop that entire column. And we called this function before. And remember, axis equals 1 because we're referring, obviously, vertically there. All right, so that's option 2. Option 3 is the option that's the best, and that is to calculate the median and then fill in any empty values. So in this case, when we're finding the median, remember, we're finding the median for that particular column. And so since we're concerned particularly with the total bedrooms, in this case, what we'll do is that if we find any of the columns or any of the values rather in total bedrooms is unfilled, what it'll do is it'll calculate the median for the total bedrooms. What's the median value for all the total bedrooms, excluding that value that's unfilled and excluding any other values that are unfilled. And then it will simply find that median and then substitute it in for that unfilled value. Okay, so you're seeing here that we're able to calculate the median. Median equals housing total bedrooms dot median. That function is going to call that, and we're going to store it in a median variable. And then you're seeing here housing total bedrooms dot fill NA median, and then in place equals true. So in this case, what we're going to do is we're seeing that if any of the values within total bedrooms column is unfilled, we're going to fill it in with a median, and we're going to set it there. Okay, so that's what it's doing. Let's go ahead and print this out. Print out the housing data frame, and let's go ahead and run this here. And you'll see here that all the values, you can't really see it from here. But yeah, you can't really see it from here. But what you can see is that none of the values are unfilled though at the same time, right? You can't really see it because obviously we are skipping some values as well, since it would take a lot of space in order to show everything. But let's go ahead and run that again, just closing that off. All right. I believe there's an error somewhere. I'll probably get this resolved and then show you why it was incorrect in the next lesson. But I don't know why there's an error coming, but I'll show it to you in the next lesson why it's wrong after doing some research. All right, so we saw that in this example right over here, just ignore the error for a second. What we're seeing here is that we filled in the missing value in this case, but what we wanted to look at was we just looked at the total bedrooms. So we just looked at one column. We want to obviously look at every single column. And so we can use scikit-learn. Scikit-learn has a class called the SimpleImputer class. And what this class does is it handles missing values. So what it does is it basically looks through actually every single column in the data frame object, and it fills in the missing values with a statistic. And we can specify that statistic. We can specify that statistic as being the mean, the median, the most frequent value. So what it could look at is it could look at all the values in a particular column that it found the values unfilled, and it could see which value occurs most frequently. Now, in our case, it doesn't make much sense to use that, obviously, because in some columns, there's a good chance that not a single value is repeated most frequently. You could set a constant value. Sorry about that. Let me go ahead and shift that. Okay, constant value, meaning that you assign a particular value. So you just say 10 is going to be the value or something like that. We could use the mean, obviously, and we discussed why that was not a good idea before, or we could use the median as well. And there's probably many others that you could use as well, but these are some of the ones that I just wrote here. All right, let's take a look at this here. So the first thing that we did here is we imported the SimpleImputer class from scikit-learn.impute, and then we created an imputer object here, an imputer instance of the class, and we set the strategy equal to median, meaning that we're going to basically calculate the median for each particular column. And so this is not actually going to be creating, this step line right over here is not actually going to be creating the median. It's simply going to set that in the configuration. Okay, so it's simply going to be configuring it. And that's often something that we do with many of these classes or many of these modules, is we'll simply send in some attributes when we are initializing an object, and we'll basically be setting in those values, but we won't actually be calculating the median in that particular step for each particular column. We would normally call a function after we initialize that object in order to calculate the median. We're just setting that into the constructor, essentially. All right? And so we're basically setting that in the configuration there. Next thing that we're going to do is we're going to take only numerical attributes. Remember that we can only calculate the median for numerical attributes. And so remember, the last column, ocean proximity, is an unnumerical attribute. It's basically, it's a alphabetical attribute. And so because of that, we cannot calculate the median in any way whatsoever. Now, in the next lesson, we will talk about how we can handle this ocean proximity column, because in the last several actually tutorials, we've been kind of dropping this column off again and again. So you might be wondering that, but in the next tutorial, we will be discussing how we can handle this ocean proximity. And one of the things that you are noticing, obviously, is that you are seeing repeated values in the ocean proximity. And so maybe think about that as well when you're coming into the next tutorial. But you're seeing here, we're going to drop ocean proximity for now because we cannot find the median. And again, when we say median, we're calculating the median for a particular column. And so when we say that a value is missing, let's say, and we want to replace that missing value with a value, the median, we're calculating the median for that particular column, okay? For that particular column. Not for that particular row or that particular district, you could say, but for that entire column, all right? So that is important, all right? So we're dropping that off, and axis equals 1 because that's going to be the vertical axis there. All right. Next thing we're going to do is we're going to call the fit function on the imputer object. Now you see here that we created an imputer object right there, and then we're going to call the fit function on that, and then we're going to pass in the housing underscore num. This is basically the data frame object using housing, which we defined right over here. And you see housing is equal to stratified training set, and we removed the label in this case, which is the median house value. And so we're basically reassigning that here, or not here, down over here. All right. So we're saying housing num, or not housing num, housing num is what we're going to call the fit function on from the imputer object here. And what this is going to do is it's going to calculate the median for every single column, regardless of whether or not that column contains unfilled data values. And so what this will do is it'll calculate the median value for every single column, even if, and this is important, even if every single column is already filled. Okay, even if every single value in that column is already filled, I should say. Okay, so it's going to calculate that there. and then it's going to store it in a variable called statistics underscore. Statistics underscore. This is the property in the object. So we have the imputer object that we initiated right over here from the SimpleImputer class, and then it's going to store the median value for every single column in a variable called statistics in the imputer object. Okay. Now this statistics attribute is actually going to be a it's actually going to be an array. Now, an array is, you might not have studied it in Python, but an array basically is similar to a list. Just think about it kind of as a list, if you would. Okay, so it's basically similar to a list. So just think about it like that, and I'll print it out for you. So I'm going to print out the median values here, and you'll be able to see it. So you see here that we have a list essentially, but it's really storing it in an array. Yeah, I think in an array actually. Yeah, so you can think about it just as in a list, right? I think if I take a 0, yeah, so it's just a list. I believe I saw it in some documentation as a array, but regardless, it is a list actually. Yeah, it is a list. So that's very simple for you to understand there. It's more simpler then. Okay, so then that's the median values there for each row, for each column. And let's take a look at these values. You can see here that our last value is 3, and remember our last column is the income underscore cat, and income underscore cat is basically determining what columns occur most frequently, right? Income underscore cat in terms of the different strata. Let's go back up here. And now that we know that 3 is our median for income underscore cat, let's go back to where we discussed this. So we discussed it way above. We discussed it right over here. So remember when we were calculating the different bins based on the median income, and we assigned different labels to that? Remember that the one that occurred the most often, the plurality of the time, was from 3.0 to 4.5. That was the median income that occurred the most often, and that was assigned a label of 3. And you can see that that occurred the plurality of the time. And so when we calculated our median for that particular column, we were able to get 3. And so that makes sense there. Taking a look at the graph, it makes a lot of sense how 3 would be the median. So that makes a lot of sense to you. So hopefully you're able to understand that, just to visualize that a little bit. And then you see also some other ones. Let's take a look at the first one. First one is longitude, or it's actually longitude. Yeah, longitude. The median longitude, it looks like, would be negative 118.1.51. And the reason why the median, remember, is not affected by outliers very much often is because of the fact that it's simply ordered data. So in order to calculate the median, we go through basically 2 steps, or maybe 3 steps, depending on how it's like. The first thing is that you have to order the data from the least to the greatest, right? And then once you order the data from least to greatest, you then take the middle value. Now, if you find that 2 values are the middle values, what you'll do is you'll do some interpolation, and you'll find the middle value essentially using interpolation. But that's why it's not affected by outliers. Because for example, let's say you had a value, let's say you had a longitude at 50, which in this case, a longitude could not be 50 because we're just in the state of California, which that would not make much sense. But let's say this was the entire world, let's say, for sake of argument's sake. Let's say the longitude was at 50. Well, the mean would be greatly, let's say there was one district that was at longitude of 50. Well, the mean would be greatly influenced by that longitude of 50, and it would be greatly, in this case, increased because of that longitude. But when we calculate the median, since we're simply just putting the data in order, it is not really going to be affected by the longitude in that particular case. Okay, so you see that there. So we were able to calculate the median there, and that's the average median. Okay, so we calculated the median, and now what are we going to do? Well, what we're going to go ahead and do is we're going to create a NumPy array with the existing values plus the calculated values filled in. So you're seeing here housing underscore num. Housing underscore num is, remember, it's going to call the transform method on the imputer object. Now remember, the imputer object stores this statistics variable, and the statistics attribute, rather I should say, the statistics attribute stores this median household values. And so when we're calling the transform function, it will be referencing the statistics attribute that we have here, or it might be calling some getter function on that attribute, or whatever it's calling. It's going to be basically using that attribute in order to create a new array using all the existing values that are already filled in and adding in any empty values by substituting in the median values here, and kind of matching them together. Let's go ahead and print that out there, and you'll be able to see what I'm talking about. I'll just go ahead and print that out. So you're seeing here that you have a list, a two-dimensional list here. And what this list has is it has basically all the columns and rows of the data set. So you can see here 2, 5, 7, 3, 3, 3. That's income underscore cat. You have longitude, latitude, basically everything. And what it's doing is it's taking all the existing values that are already filled in, and then it's adding in all the empty data values with that median values list there. And it's mapping each of those median values to the appropriate columns there, where it would not be filled in. Okay. And now remember, this is a list, two-dimensional list, but we want to convert this back into a housing data frame object. And so the pandas has a function called data frame. Or I think it's an object. We'll cover that later. But it's data frame, and it's going to take in that list, but it's going to set the columns as being equal to housing underscore num dot columns, and that's just going to print out the different column names, as well as housing underscore num dot index. That'll just be storing all the index auto incremented there. Let me go ahead and print that out, and I think it's a lot of unnecessary things here. But anyways, we have longitude, latitude. You see there, that list there, and then you also have the indexes there. So you're seeing here the index